All right, welcome back. We are COMP397 in the winter 2020 semester at Centennial, and we're week 5, part 2 of our broadcast talking about finite state machines. Finally. So what is a finite state machine and why do we need them? Well, right now what we have is one scene. We have game.ts. And what if tomorrow, right, I have 10 scenes, 20 scenes, 30 scenes, 50 scenes. I could have each scene is its own function. So I have one function that says function scene 1, function scene 2. And maybe that function is going to have a bunch of code. Let's say 200 lines of code for each function. So if every function has about 200 lines of code, which is fairly complex, with a lot of other little function calls inside of it, I might have with 10 functions, 10 scenes, I might have thousands of lines of code, potentially, right? Crazy, every time there's some kind of noise. So thousands of lines of code, and it's all in one big file, like a big file with thousands of lines of code. Completely unmaintainable and really, really difficult from a manageability perspective. And even now, with small amounts of files, we have this problem. Our stuff is set up like this. We have right now an outer container, right? And this outer container is the game. So here's the game. Right? My game object, my game application, think about this as the application, at the application level, the game. Inside of it, we call a couple of structures. One of the structures that we call inside is the canvas, which is an HTML canvas right now. So HTML canvas, right? I'm just going through the explanations so you understand what the problem is that we have. So here's the HTML canvas. Okay, cool. And then inside the HTML canvas, we make a reference to the stage, right? Which kind of lies in here right now. And this is a create.js stage. Create.js, so a stage, which is of type create.js dot stage. That's what it is. Okay. So here's this. Right here. And then what I have is a bunch of game objects, right? And what I want to do with them is add them to the stage. I add them to the stage here, maybe over here. And then, you know what? I have a function, and I call the function, and then it deletes all those objects one by one, right? Or all together. And when I delete all these objects, I have to manage them. Each object right now, I have to do this. I have to update the objects. Maybe I have to clean up the object. I have to do that for each object individually, right? And I have to manage each of my objects separately, okay? And there's some other ways to do this. I can use the display list and remove all children. I can do those things with the stage because the stage is a container, right? But this becomes more difficult to manage, like I talked about. We need other structures to help us because I want to go from one scene to the other. I want to go from scene 1 to scene 2 to scene 3. I want to be able to compartmentalize those scenes into smaller chunks so we can manage it easier. Because right now it could be very, very big. Lots of stuff, right? So I don't want this. This is not good. Instead, what I want is something that looks like this conceptually. I want this other box that's inside here, right? And this box inside here is a scene. And a scene is going to extend create.js dot container. And I want to explain what the container is in a second. So it's going to be an abstract superclass again. And what's going to happen is there's going to be other scenes that are loaded into this space. So now I can have different objects, just like before. So let's say I have an object here, and an object here, and an object here, or maybe some objects that are smaller. Who cares, right? They're all part of the scene. And I don't even have to manage all these objects the way I'm doing right now. I can just kill the entire scene. And when I kill the scene, all the objects die too, right? The challenge that I have to have is that the scene would now, all the objects normally will be added to the stage. That's not the case. And if we look at the documentation online for Easel.js, And if I go to the container class that they've provided for us, here's the container class, right? If you think about what this is, the stage itself is a container class. So stage, you can do add child. So too can you do for all the container classes. So if you want to make a super duper game object, let's say the player, and the player is going to have other game objects inside of it. You'd make the player a container, and inside the container, that container, you would add child other objects. But let's not digress. If I go back to the container itself has add child, get child by name. I can remove all children. I can remove a specific child. I can do all kinds of stuff the same as if I would have with my stage. Okay?
Can I place a container inside your?
Yes. Which is a beautiful thing. That means I can have a lot of structures. Now, warning, containers, like it says up here, is a nestable display list that allows you to work with compound display elements. But it says, you know, be careful how you use these things because they are computationally expensive. He says you shouldn't create a container to hold a single child. It doesn't make sense because containers they have some overhead, which means don't do it. Don't make a container to hold one thing. Make a container to hold many things. Then it's worth it, is what it's saying. Okay? All right. So this is going to be a container, and it's going to hold many things. And what's going to happen is each of these objects are going to be children of the container. So this is the children of the container, right? But this container is going to be a child of the stage. Right? So it's going to be a parent of all these children, but also a child of the stage. Right? Are you with me? All right. So that's what I want to do. That requires a scene class, and I'm going to make 3 scenes today. Start scene, the play scene, and the end scene. And they're all going to be a scene. Then we're going to talk about a finite state machine. Once I make that, I want to be able to switch between one scene and another scene. It's going to take a little bit of memory management. I want to kill everything that was in the scene before. And then I want to instantiate the new scene. And I want to be able to switch to that scene outside of my scenes somehow. So we need some structures that we don't have right now. And that's the rest of the time we have together. Let's start this off. This took me 2 hours when I did it last time. Hopefully it won't take me 2 hours again. Because the second time around, hopefully you guys can do it a little better. Number 1, let's add some more structures. I want to add a new object called the scene class. So new file. I'm going to make a new scene. And we'll make it scene with a capital S. Scene.ts. The scene itself, like we said before, is going to be in objects module. Right? It's going to export a new abstract class called scene, which is going to extend create.js.container. Okay? So scene is a container. Okay? But we're going to add more functionality to it. So a couple things we know we're going to need some, maybe some private instance members. We don't know yet what we're going to need. We're going to need some public properties, maybe. And I like to use this pseudocode kind of thing at the beginning for myself to set up some structure for myself when I start coding. And I recommend it to you too. Okay? I know I need these things somehow. Maybe some of them, maybe all of them, maybe none of them. I don't know. Right? For sure a constructor. And the constructor for my container is very simple. Okay, so constructor. And I'm going to call it the super constructor, which is like literally that. Because super constructor takes nothing. Containers doesn't take anything in the constructor. That's your constructor for the container. Okay, here are my public methods. And I want these to be my lifecycle methods that all other subclasses are going to inherit from. So these are lifecycle methods. Lifecycle methods. Ready? It looks like this. I'm going to make a public method called start that's going to return void. And it needs to be abstract. Abstract means I just declare it, but I don't define it here. I just declare these methods. So again, another one, public abstract method called update. All scenes will have this. And a public abstract method, right? So start, update, and main, which is where the work happens. Start, update, and main. Are you with me? 3 methods. Let's define these more. So I can use some documentation help to say that this method is used for initialization. Right? And this method here, this method is used to update all objects, and we'll say all child objects in the scene. Okay? And this main method, this one is going to be used so that way we do all the work here. This method is where all the work happens. So things like moves around, I want to make some calculations, I want to do something, I want to add things to the scene, that's what's going to happen there. Okay? That is my scene class so far. It's pretty simple, right? But I've got 3 abstract methods. The whole thing is abstract, which means if I inherit from scene, then I'm going to, I need to implement these 3 lifecycle methods in order for me to implement scene. Okay? Hey, yes?
Using the main program, we have to call these life cycle methods, or it already is controlled by the
Doesn't know. We have to make sure. You'll see.
Okay.
Bear with me. I like your questions, but let's get through this because otherwise it's going to be a long time. All right, next, I want to make sure that it's added to my stuff. So index.html, scene, okay, it needs to know about some stuff. My scene probably needs to know about vector and game objects, so I'm probably going to put it down here. So script, source, /scripts / objects, and then scene.js. So that's where it comes in. So here that scene is added. Now let's add scenes. This is just the abstract blueprint for my scenes, right? I want to add all the other scenes that are kind of inheriting from this one. Okay. So when I go back, the way that works is if I go into my folder structure, I want to add another folder. I'm going to call this folder scenes. Inside my scenes folder, I'm going to first start with the scene type. Call this the scene state. I'm going to make a new file. I'm going to call this state. And my scene state. The way you read stuff now from now on is the folder first, scenes, and then the name second, state, scene state. Objects button, objects game object, managers collision, right? But you can also read it the other way around. Collision manager, which makes more sense, right? State. State scene doesn't really make much sense. And how about objects? Button objects, that makes more sense, right? So think about this. What I want here is it's going to be in module scenes. And inside module scenes, I want to have a new class, a new enum. We know what an enumeration is, right? We're going to call it state. Oops. State. In my state enum, I'm going to have the following states. No scene. which I'm going to set to -1. The start scene, the play scene, the end scene, and then number of scenes. Well, what does this mean, number of scenes? Well, how do I use number of scenes? Well, I know that if this is scene 0, this is 1, and this is 2, well, the number of total scenes is 3. And if I add more scenes, this number will increment. I can always go to state number of scenes, and I know exactly how many scenes there are. 5, 10, 50, 100, doesn't matter. Okay? So this is an enumeration. This is going to keep track of my scene state. Which scene am I in right now? Okay, I need this one. By the way, just to be curious, what does the scene state enumerate? What does an enumeration look like in old JavaScript? It looks like this, actually. Right? So what it does is it creates an array. Here's my array. And it's an associative array. This associative array provides a nice friendly name for the array. And then it assigns two things, right? The associative array assigns a value, and the outer array takes the associative array as the associative array's name and assigns up another value. So there's two values, one on the inside and one on the outside, and that's how it handles enumerations. Because in JavaScript, my friends, even ECMAScript 6, there's no enumeration yet. And this is why we use TypeScript. Because TypeScript makes JavaScript easier and more recognizable compared to other programming languages like C# and Java and C++. Okay? Cool? Yeah? Okay, excellent. So we have our scenes and we have this stuff. You know, we have our state. I want to make a new scene now. So a new file, right? Well, let me talk about this for a second, right? Every scene will have a state in a second, but we'll talk about what this is going to do for us. Okay, new file. We're going to make a new file, a new scene, and it's going to be called start.ts. This is going to have a class. So again, module, scenes, and then export, class, and then this thing is going to be called start. It's going to extend the objects.scene. And notice I have this little underline, my friends. And it says, non-abstract class start does not implement inherited abstract member main, because these are things that it's expecting. So if I click onto here and I go down to quick fix, it says I can implement all these members, which makes my life a lot easier. Because now I can do, now I can look at all these members for myself like this, and I can just wipe out these things that I don't want. Oops. So I want to get rid of this, and I want to get rid of this, and I want to get rid of this. Those are my implemented functions. I'm also going to need a constructor. So again, I'll do the same thing. So private instance members, right? And then there's going to be maybe some public properties. Maybe I will, maybe I won't. But I want to set this up. Constructor. And then some public methods, right? And maybe even some private methods. Oh. Okay. Let's do the constructor first. The constructor is going to be pretty simple again. The constructor is going to call the superconstructor, which doesn't need anything, and it's going to call the start function. So first the constructor is created, then it's going to call start. Start is going to do some initialization, and then it's going to call main. This is the same structure we had in our game. I'm mimicking the same structure we had. I'm just putting it here. Okay? So this is the structure of my scene, any scene. Let's add this to my index.html so we don't forget. So index.html. Now, I'm going to put it somewhere where it knows stuff. I need to know about labels and buttons. It needs to know about collision management. It needs to know about all this stuff. So scene should go right at the bottom, just before my game. And then scripts, scenes, and then we'll call this start. Okay, so scene, start has been added. No problem. Excellent. And what I want to do with my start scene now is I want to take all the stuff out of my game. I'll be here. So all of this stuff that's in game, this stuff, and put it in my start scene. We're going to have some problems. But here's what I can do. I don't need a welcome label, a start button, and a player anymore in my game. It's only going to be in my start scene. So let's take this off. So these ones gone. It's going to create some errors, but this is good because then I can know what I need to move, right? So I'll leave the errors here for now. Go back to start. And then at the top in my private instance members, I'm going to put them in. I don't need lets because it's a class. So I can get rid of let, the let keyword altogether. It's complaining about welcome label, start button, and player. And the reason why it's complaining is because it's not being initialized anywhere in the constructor. We're going to fix this one step at a time. Next, let's go to the next part that I need to move. Okay, so player.update and managers AABB check player start button. Okay, take this out of this update and let's go back to my start and put it in that update. Okay, let's make sure it's right. So it's this dot player, right, and this dot player and this dot start button. Okay, so that's okay. Everything so far so good. Back. Let's keep going. All this stuff is going to come out. We're going to put everything in main for now. All this stuff. Okay, except for this. Actually, we'll take this as well. So cut all this out. Now, is there any errors left? No. There's no errors left in game, but there's still stuff we have to do in our start. So in main for now. Let's put that in there. And let's change this. We'll add the this keyword to everything for now. And then we'll fix it. Okay, what about stage? Well, we're not adding it to the stage. We're adding it to this. Because this scene is a container, we can do this.addChild. Okay? Which is pretty important to know. So again, this is just this, .addChilds. And I'm just going through and changing and adding the this keyword to represent the object that we're talking about. Okay? We can't do this like this. Welcome.on. We have to change this function to an arrow function. Otherwise, it won't work. Okay? So like this. Because arrow functions like this retain their context of the parent. Okay. We got this player, and again, it's the same thing for this arrow function. We'll make this into an arrow function. Right? We won't make it into a regular function. Okay, and then this will be this. And this will be this player. Okay, we have a couple of errors still. These things need to be initialized. And we'll just do that in the constructor. So we'll say that some initialization. And we'll say that we're going to take all these things here and pop them in there. And we'll say that this dot and we're not going to say that. We're going to say that this dot welcome label is equal to a new objects dot label. Anything we can make some basics will do. This is equal to a new objects dot button, and this one here will be a new objects dot player. Okay, so just initialization stuff. Now you might say, hey Tom, didn't you see the start is initialization? Yeah, it is, but these look for the constructor. Okay. Okay. That's this. And then what we can do is when we scroll down, we can see any other things we need to set up. So start does this right now, doesn't do much. However, maybe what I want to do is I want to split up this stuff. Add child is something I want to do here, but I want to instantiate everything in start. So that's where it's going to be done. So I want to break this up a little bit from a maintainability perspective. So I want to put that here. I'm just reorganizing. That's all I'm doing. Okay. And I want to take my start button. Right, and I'll put that in start too. And I also want to take my anything I'm instantiating basically. So here's the player. And I'm going to put that in start too. Because start is a place, the best place for me to initialize stuff. And this place here is going to be where I'm going to do work, which is what I'm doing here. Okay. And if I want to, I can kind of Control A. I can right click and I want to format everything. So format selection. It says there are multiple formatters for TypeScript files. Select the defaults. Sure. Let's just select prettier. And that's a beautiful thing. Notice what it did. It kind of, I don't know if you guys like this, but what it does with a parameter list, prettier, it goes through and it splits off the parameter into different parts. I mean, to me, I'm okay with this. It just makes it so it's more visible and maintainable. Some people like it all on one line, and if you really want to, you can undo that change, right? And you can only set up what you want to do, in the area that you want. I mean, I personally think that this definitely has to be formatted, so you can just pick an area and then just format. Oops, did I just do that again? I can format. Instead of formatting my document, I want to format my selection. So that's okay. So that it'll make it so it looks nice. And of course it did everything. So much for formatting my selection. Yeah, but anyways, there's formatters to go through to make it look nice. Right now it doesn't look so nice, but it does what it's supposed to do. And there's probably some simple things I can do myself to go through and format everything properly and get rid of some white spaces because sometimes it makes things confused. One thing we want to do that I like is to put my curly braces on different lines because then you can see this line that comes down from one curly brace to the other. It makes it easier for you to find errors, right? So you can see that this way I want to make that all curly braces are kind of on the same line. That's kind of the format I like to use. And this is pretty good now. All right, now that I have this, great. I have a start scene, but I want to make this start scene. I want to get the exact same effect that I had before. I had my game, but now I want to have my start scene in another file, and I want to load that scene in my game. So let's go back to game. We're going to have some problems. We're going to have problems. So instead of loading game objects here, let's load a scene. So let our start scene. This is not how we want to do it long term. It's of type scenes dot start. Okay, that's what it is. And what I want to do is I want to update my start scene. So start scene dot update. Right? I want to update my start scene. And I want to instantiate my start scene, maybe in main. Maybe I'll do it here. I'll say start scene is equal to a new scenes.start. Right? And then what I want to do is stage.addChild start scene. Because I'm loading the scene, I'm taking the start scene and I'm attaching it to the stage. The whole scene now is attached, just like we did in that diagram. Okay? Here I'm updating the entire scene. My scene is updating all those objects. It's a cascade. My object is updating itself. Right? Make sense? Let's see if this works. So I'll save everything, and if everything works, and by the way, I know certain things are not going to work. We'll talk about those things. Let's see what happens. All right, so we're good, but are we good? So do we have collisions? Let's take a look. So I'm going to inspect, and I'm going to go to console, and my collision detection works. No problem. Everything's okay, right? Actually, it worked better than it did this morning with one blow. I spent, guys, half an hour, 40 minutes troubleshooting to make sure this works. So everything looks like it works, right? Exactly the same. There's no difference. Right now, you don't even know that I have a start scene. All you know is it looks exactly like the other one. Okay. But I want to be able to switch. I want to switch from one scene to the other scene to the third scene. And I'm going to use something called state machine pattern. Like we talked about before, back in the day, there was this gang of 4 programmers. Did I talk to you guys about this already? The gang of 4. They created 23 design patterns. Okay? So gang of 4, if you look them up. And they created this design patterns. These are the gang of 4 right here, right? These people right here. And back in the 90s, 1990s, they created a book, 1994, they created a book all around programming design patterns. Why? We had, at the time, object-oriented programming was hot, and they noticed that some design patterns, some patterns emerged over and over again, and everyone did them slightly differently. And they said, hey, why don't we get together and we make a book that has the best practices for using these design patterns, and even tell other people, instead of them trying to reinvent patterns, here, look, there's some stuff we've already done, and these patterns are successful, these 23 patterns. As developers, you guys should know about the 23 patterns, and eventually should know probably about half of them, right? For example, Singleton design pattern is something you all should know about. You guys should have learned about it in COMP397, Singleton design pattern, okay? That was like programming 2. And factory design pattern, we've also talked about in programming 2. So factory, Singleton, those 2 things. And there's different kinds of design patterns, creational, structural, and behavioral. From a creational structure, a creational pattern perspective, factory and Singleton are the 2 design patterns you should definitely know about because you were taught them, all right? Or you should have been taught them. Structural wise, that's a different thing. You may not have had access to these things, or there may not have been a call for you guys to have these things. So maybe not so much structural, but behavioral you've seen. If you've done an event handler, like we're doing right now in JavaScript, that's the observer pattern. The observer pattern has a list of subscribers, add event listener. I subscribe to the observer. The observer observes an event, the click event, the hover event, the hover out event. And when the observer sees that that event is triggered, it notifies its subscribers. That's the observer pattern, all right? So we know that one for sure. And then the other one that you're going to talk about today is the state machine pattern. And the state machine pattern is like this. I have different states. For example, let's suppose I'm playing a video game, right? And I see an animation of an idle character in 3D. So the idle character is just breathing like this. And then something happens, right? You make the idle character move by pressing your buttons. And now he moves from an idle state into a run state. So he's running this way, right? It's behavioral. And then I run the other way, right? So I run left, run right. Okay, then I stop, back to idle again. And if I jump, that's a jump state. I land, that's a landing state. I get hit, that's a hit state. I fire my gun, that's a fire a gun state, and so on. It's all these different states. You can move from one state to another state. Not just from a behavioral perspective, but also the way you look, like animation state, right? So we have that kind of thing. You can also have an artificial intelligent autonomous character that runs around the scene trying to attack your character, right? So autonomous characters can have also states. They can be in a seek state. I'm looking for you, right? I'm looking. Or a patrol state. They see you. I see line of sight. I detect you. Fine. I'm going to be into attack state. Great. Then you hit me and I take damage. Now if I took too much damage, I'm into flee state. I'm running away, right? So I go from one state to the other. And this is all automatically, autonomous, through when you create your artificial intelligence for your games, right? AI for games. So states can be used for a lot of different things. And when you read the state pattern, so if you actually click on this state itself, It talks about the state pattern and what it does. It also gives you some diagrams to help you understand. And this is just Wikipedia, by the way. But there's a fantastic book for people who are interested in game development, and it's called Game Programming Patterns. Game Programming Patterns. Game Programming Patterns is a free book that's online, and you can also buy it in print. It's a really great book to own if you're interested in game development. But on the web, he talks about, this is Robert Nystrom, and he talks about different design patterns that are specifically for game development. Here's state pattern, and he talks about the challenge of states. So for example, he's talking about movement states, a character that's jumping and then landing and then running, and how to control different states that a character has in midair, when they're landing, when they're moving, when they're turning, all these different things. How do you do it? And he talks about how sometimes we want to use these Boolean variables to kind of say, it's true that he's running. Now he's not running. False. Booleans are bad. It's difficult to manage, and it becomes very difficult to maintain. A lot of Booleans that turn off and on. But using state machines, which we're going to talk about before, or in a state, we're going to basically look at an enumeration, which you just made. Start, play, end. Which one am I in? I'm in start? Okay, cool. I can transition from one state to the other state. I can move from start to play, from play to end, from end back to play, and so on. And I move from those states, and then each state has its own associated behavior, like a scene. When I go to the scene, right now I have a player and I have a button. And if I go to my end scene, I may not have that. I might have other behavior. I go from one set of behaviors to another, different states. That's how they work. Okay, if we know this, going back to the game, right? I don't really care to have in my game a player in my start scene. My start scene player was just for testing. That's what it was for. So let's get rid of them. So no more player on the start scene. And I'm just going to go clean up the player. So there's my player start scene gone, right? I don't want to have my player in my start scene. Okay, I'm not going to do check collisions. I put this check collision stuff for you guys, so you know how to make collision detection. But I don't need my collision detection in my start scene. And I get rid of it all. And I don't add it to the scene anymore too. Okay, so there we go. So now my player is gone. No more in the start scene. And if I run this thing, if I go back to my code, you can see now that there's no player in the scene. Here's what I want to do. When I click start, I want to move from the start scene to the play scene. When I'm in the play scene, I'm going to click next. And I'm going to go from the play scene to the end scene. And when I click back, I'm going to go from the end scene back to the play scene and back and forth. I should be able to navigate between scenes this way. All right, cool. I like this. So instead of instantiating in my game a single scene, here's my game. Instead of instantiating a single scene, I don't want that. I want to keep track of two things. What's the current state? Am I in start state, play state, or end state? Which one am I at? So I need current state. So instead of the start scene, let's get rid of this. And we'll say this is, we'll change the current scene, or start scene, to something called current scene. But we're going to get back to this. So right now I need something called scene state. So current scene state. And this is going to be of type scenes.state. Current scene state. I'm also going to have the current scene, the actual scene itself, the scene object, the container. Okay? So one is the state. It's a friendly name. Start, play, end. And then the next one is the actual scene. But we don't know what scene it is, so we can't name it. I'm not going to load all the scenes and switch between them and have them all open. That's just not efficient. What if I have 50? What if I have 100? I'm going to have 100 scenes preloaded? It's crazy, right? I only want one. And the way to do that is I can say let current scene, which is of type objects.scene. Remember, all scenes are objects type scene. They have an is a relationship. I don't know which scene it's going to be, but I want to keep track of that. Next, In my update, I'm not going to update a start scene. I'm going to update the current scene, whatever that is. I don't know what scene it's going to be right now, but whatever it is, I'm going to update it. In my main, I don't want to have this anymore. I don't want to instantiate stuff like this in my main. No, no, no. In my main, I'm going to switch my scene. That's what I'm going to do. Scene switched. Okay? That's what's going to happen in my main. Whenever I switch my scene, I'm going to come to main. Okay, here's the challenge. How do I know my scene needs to be switched? I need to listen for it. I need to listen for it every frame. If my scene is switched, then I'm going to change my scene from whatever my current scene is to whatever my new scene is. That's what I need to do. But somehow I need to keep track of my old scene and my new scene. What the heck? How do I do that? Right? I mean, I could have variables. Old scene, new scene. If old scene is equal to new scene, well then, okay. But if old scene and new scene are different, that means something's wrong. Something's switched. And I need to fix that. But instead of doing it this way, let's keep current scene. And now we come to the point where it might help if we had some other kind of structure, some area where I keep track of my global configuration for my game, right? And I can do that with inside another namespace, and I'm going to call that namespace config. Now you can do this in different ways. This is the way I'm going to give it to you. So I'm going to right click on script. I'm going to make a new folder. I'm going to call this folder config. My config folder is going to have another file inside of it called game. Not to be confused with this game. There's a game inside config. Game config. Game configuration. That's what this is. And it's going to be a class that looks like this. Modules config. Or module config, I mean. Oh. And inside my module config, I'm going to export my new class called game. Game. And you're like, wait, we have a class. We don't have a class called game. This is the first time. Yeah, this is a game config class. We can have multiple classes called game. This game class is inside the config namespace. This is a public static class that's going to have one public static property right now. And this property is going to be called current scene. So current, or I'll just call it scene, which is of type objects.scene. That is what we're going to have. So you're like, wait, I don't get this. Why have this here? Well, because I can store in this global little storage place what my current scene is. And then if I want to change it, instead of changing the one inside my game, I can change this one. And if I compare the one that's in my game that's current with this one, and if they're different, then I know I need to make a scene change. Okay? So this is what we're going to do. But in order for me to do this, I need to record my scene somehow. I need to record it somehow. So I'm going to go to my, game. This game out here. And whenever we made our scene. So here we have a scene as an example. We have a, we're going to have a scene state. I want to record it. And I want to get rid of this main reference. I'll talk about this in a second. So here I'm going to say that, well, current scene state, right? Well, that's going to be equal to scenes.state, right, no scene. So I start off, I don't have a scene, right? Then I'm going to set up config.game.scene. I'll make that equal to scenes.state.start scene. All right? Did I do this right? I did not. Hold on. This should be scenes.state. Okay. So now you can see that these are different, right? One is the no scene and the other one is start scene. Because they're different, I want to switch. I want to swap, right? From no scene to start scene, but only when these two things are different. Well, they're different now. So where do I check for this? In update. I'm going to say that if my current scene state is not equal to my config.game.scene, then I want to go to main. I don't want to go to main here. I want to go to main here. And when I go to main, which is in here, I want to consider a couple things. One, if I'm going from one scene to the other scene, I want to clean up the previous scene. So I want to do some cleanup. And then, this is my pseudocode. And then I want to switch to the new scene, right? Those two things I want to do in main. So first clean up and then switch. Okay, but what if I've never gone to this, I wonder if I don't have a scene that I've loaded before. Like now, I don't have a scene, I have no scene. If I try and clean up something that I don't have, my program's gonna break, right? So I can't do that. I have to check to see if I'm in that scene. So I'm gonna say if current scene state is not equal to scenes.state.noScene. If it's not equal to this, if it's something else, then clean things up. And the cleanup will be like this. Take my stage and remove all children, right? I want to remove all children from the current stage. I also want to take my scene, wherever my current scene is, and I want to remove all children from them too. Remove all children. So I'm removing all children from the current scene, whatever that is. Then I remove everything from my stage. I'm cleaning everything up, okay? But only if this is not the first time through. If it's the first time through, I avoid this thing because I don't have anything to clean up, okay? Then I want to switch. And I want to use a switch case. Switch on config.game.scene. If my config.game.scene, there's going to be three cases right now. The first case, right, is going to be scenes.state.start, then do something. Or scenes.state.play, then do something else, right? Or scenes.state.end, finally do something else. Those are my three scenes I'm going to have, right? I'm going to switch these up. And the first thing I'm going to do, if it's my start scene, because I have that one, I can say that the current scene is equal to, this is where I instantiate a new scenes.start. So here I instantiate a new scene. Okay? And I want to do the same thing. I don't have these yet, but I want to do the same thing for play. And I want to do the same thing for end. Okay, but I don't have these two, so I'm just going to comment them out for now. But that's what it's going to be. After I'm done switching, after I'm done, I want to do two more things. I want to set my current scene to config.game.scene. I want to make them equal now. They're the same now again, right? So current scene state is what I meant. I want to make that equal to this. And then I want to take my stage and I want to add child my current scene. Doesn't make sense. Think about this, right? Let's run through it one time. Okay, so I'm up at the top. I start my game, and then I come into here, and it says, okay, my current scene state is no scene. But guess what? My config.game scene, the one I'm holding in memory, right? That's start. Cool. I'm going to go every frame and look at update. Let's go look at update. Okay, here's an if statement. If my current scene state is not equal to config.game.scene, and they're not, one is no scene, one is start, I'm going to go to main. Main. Is my current scene state not equal to no scene? No. Right now it is equal to no scene because it's the first time I'm doing it. Okay, cool. Skip this. Go to here. Switch. Whatever my config.game.scene is, which is start, it's here. Instantiate this. I make a new start scene. Yay, excellent. And I set a reference. I set the reference into my current scene. Cool. Then my current scene state, I switch it now, so it's the same as scene in the global space, right? And then I add my current scene to the stage. Great. Now I come back up. Am I making a change? No. But let's update my current scene every frame. Everything that's inside that current scene, I'm updating, I'm updating, I'm updating. Until something changes. Let's see if this just works the way it's supposed to work. Now, there's a couple things I made a change to. One thing I added was my config. And I also added my start. I need to add those things and my enum, those three things, into my index.html. All right, so let's do that. So index.html. Here we go. So first, my enum, my scene state. Does my scene state depend on any of this stuff? No. So I can put it up here. So script, source, scripts, and then again it's scenes, and then state. That's that. That's in. That's my enum. Okay. Then I have my config. My config needs scene state. It needs it because it detects scene state. So I'm going to put my config up here. So script source dot slash scripts config game. So that's my game config. These are, in fact, these are like higher order scripts. These are like almost like script or component scripts. Component scripts. I need them for the game, right? These in here, this is where I'm going to put all my managers, I hope. Managers. Down in here, I'm going to put all my game objects. And then down in here, I'm going to put all my scenes. See the order? Organized. Try and be as organized as you can because you're going to work with somebody else on this. And they need to know what you're doing. And you also have to keep track of everything you've got in your index.html so you know there's no mistakes. If I left one of these things out, you're going to be busting your brain trying to figure out why it's not working. You're going to go, did I add it to my index.html? You're going to make this, all of you are going to make this mistake. 100%. Until you do it. Okay? Cool. So I've done this part here and we should be able to run it now. I've added everything to the files. I saved everything. Let's make sure we just click this Save All button. And if I go back here, we're good to go. You may not see a change, but you can see it inside of my console. See? Scene switched. That's the change. If you want to know which scene switched, let's do that. Let's go into my game.ts. And when I switch scenes, I want to know which scene is switched to. So here's my start scene. Let's just say console log switched to start scene. And just to be fair, whenever we do the other ones, we'll switch to the play scene just for our own thing right now. And later on, when we make the game, we'll take these out. But for now, I want to go to my play scene. That's silly. Play scene and end scene. I don't have those yet, but I want to see this change. So if I go back and if I press this and you can go to console, you can say switch to start scene. You know it went there. So I went in here, right? Here, and then I went in here because this switch case worked. Make sense? Okay, cool. Let's make 2 more scenes. Play and end. And then I'll let you guys go. All right? And I'm going to do them very quickly because I'm going to copy the start scene a couple times. All right? So scene, new file. We're going to call this file play. And we're going to make another one. We're going to make this file end. Okay, so we have 3 scenes. Start, play, and end. Hey, just because we have them ready, we go back in my game.ts and uncomment these ones, because now it's okay. Here's play, and here's end. But I'm going to define them, so I'm going to get my start. I'm going to select all, go back into play, paste, change my start to play, right? Go back to end, paste, change my, actually, let me undo that. I'll come back and do this second. I know there's some things I got to do in play. In play, instead of a welcome label, we're going to have a play label. Let's rename this thing. So rename label to play label. Instead of my start button, this is going to be called the next button. Let's rename the symbol. Next button. Okay, cool. Everything's still the same. Okay, instead of saying the game, I'm going to say play scene. So we know what that's true. Okay? Hey, I have a start button, but it'd be really great if I had other buttons. Let's make 2. Okay, so I'm going to go into my 5C. I'm going to go to my assets, images, and I already have a couple of buttons. I have reset. That's pretty cool. I like reset. But I'm going to make next and back. So I'm going to go into my little program here. And I'm just rename this to next. There we go. File, save as. Right? Call this next button. Okay, and we'll do the same thing. I'll say back. Okay, we have a couple more buttons, right? And by the way, these are like super quick buttons. Buttons all do the same thing. They all hover over and change transparency. That's all they do right now. All right, so that's good. Excellent. Let's just change this to the next button. Okay, nice. And instead of the next button saying clicked, no. Let's not say clicked. We'll do this. Config.game.scene. Well, that's equal to a scenes.state.play. And because I changed my scene now here, every update it checks for changes is going to compare my current scene with this scene, and there's going to be a change, and it's going to swap scenes to go to the play scene. That's how it works. Okay? Cool. So that is the switch. By the way, you could change this if you died. Let's say you collided a bunch of times and died. You can go to the end scene as an example. And we're going to do that. This is actually play. This should be end, not play. In my start, I got to change to play. I got to change this in my start. So that's one thing I forgot to do. So in my start scene, in my button, which is what down here, let's change this to play. This will be play. Right? Cool. So I have my start and my play scene. They're looking pretty good. I'm going to select everything in my play scene, going to go into my end scene and paste it in. And then call this ends. Scroll down. Let's talk about this. The play label. It's not going to be the play label. It's going to be the end label. So I'm going to rename this one. We'll call this end label. We'll call the next button a back button. Rename. So rename symbol. Back button. There we go. Scroll down. Instead of end scene, it's going to say end scene. Play scene, end scene. And instead of the next button, we're going to make this the back button. Okay? Again, just swapping stuff around. When I click the back button, it's going to go back to play. So it's going to be like a reset. And we're done. Okay, let me take a look at one thing we need. My index.html. We need 2 of these. 2 more of these. Okay, question for you. We might need to know what end scene is or the other ones. It really doesn't matter the order here, right? But many times what I like to do is put the in reverse order. So I put ends and then play and then start. Okay? And I do this because maybe, I don't know why, not now, but maybe something in play start's going to have to know about. Like example, I don't know, maybe the player, maybe I want to pass some information from start to play somehow. I don't know. For now, I don't need it, but I'm putting it in reverse order, right? Okay, so now I've got everything I need. Let's see if this works. So going back to here, I see the game, and now let's take a look. Start. Oh man, what the heck? What happened? Did it even work? The game. Start. Oh, it broke. Okay, let's see why it broke. So now we're going to do some switching. It says switching to play scene. Okay, cool. Switch to play scene. It switched to play scene, but nothing played. What happened? How come nothing showed up? Right? Let's refresh and see what happens here. So here, we're starting off. We're switching to start scene, right? Then we're clicking start. Switch to play scene, but we don't show any errors, and we don't show anything. What happened? Well, let's follow the logic. It went game T71, right, which is here. It went to, well, yeah, they're commented out somehow. Maybe I forgot to save my game.ts. So is it right? Did I forget to save my game.ts? Yes. It's not saved. So save it now. Let's go back. Okay, let's try it again. So here's my game. Start. Play scene. End scene. Play scene. End scene. And now we're moving from one scene to the other. State machine pattern, right? And now you have 3 scenes you can use for your game. The start scene, the play scene, and the end scene. If I want to use other scenes, here's some examples and some good ideas for scenes, okay? I could have a transition scene from start to play where I fade in. The whole scene, all it's doing is just fading to black. You know, like a fade in and a fade out scene. I can have those 2 scenes. All they do is have this big texture, a black image that just loses all of its transparency, or I make the whole scene fade out. Or because the scene is a container, I can move the whole scene in at once. I can move it because it's a container. I can move a container around my global space, right? By default, each container is centered at the top left corner. So I can just move that scene around. I can do screen shake, right? Where the whole screen shakes with some kind of sine wave, right? I can do all kinds of stuff right now because of this. Each scene is unique. It's a unique world. That means once I go from one scene to the other, the scenes right now don't talk to each other. They're completely unique, okay? So really awesome stuff, guys, that we can do right now. And this is the beginning of the stuff that we're going to do for the remainder of semester, all right? We're finally at the beginning. I know, this is pretty crazy. Now we're at the beginning, right? Because here's why we're at the beginning. We have our game object. We have our vector class. We have our scene class, right? We have our structure. We have our config file. We have everything we have to start building. We can build. This is all the Lego bricks that we need to build up our game from now on, right? Before, it was like we were still building. Now, certainly there's more stuff we can add to make this more complex. For example, if I was going to diverge, I can make different games now. If I want to make a physics type game, maybe I'm going to put some velocity with my game object and acceleration, right? I want to think about physics components of those objects. If I'm going to make a top-down shooter, right, like a space shooter, I'm going to add bullets and other kinds of enemies to my scene. Maybe some AI, right? If I'm going to do a tank game, right, maybe I'm going to add some destructible objects, things that destroy, explosions, all those kind of things that I need. And we haven't talked about sound or preloading yet. So those things we're going to build as we go forward and in the next weeks to come. I'll tell you right now that the play scene, this whole start scene, play scene, end scene, will be on your midterm test. It's going to come, right? Your midterm test is going to test you on, do you know how to do Create.js? Do you know the structure? If I gave you a structure for Create.js, could you launch everything? Like, do you know how to unzip stuff, get a template, use it, like basics, okay? Do you know about buttons and labels? Did you make your slot machine yourself, or did you get someone else to make your slot machine? How did you know it? Do you know how to make random numbers work? Because games use a lot of random numbers, right? Basic things. That's what I'm going to be testing on your midterm. Midterm is going to be 3 hours. I'm going to give you 3 hours, but it's only going to take maybe an hour to do if you know what you're doing. If you don't know what you're doing, it could take the whole time. It's going to be very casual. You're going to be able to go up online, look stuff up. You can see my code, your code, whatever. Can't copy anybody else's code, but you'll be able to see examples, right? And you may even be able to talk to each other. It doesn't matter, because I'm going to give you a certain amount of time to do everything in that time frame. And if you don't know what to do, it doesn't matter. You can have unlimited time. It won't matter. It's going to be here for this one. Let's hook back to that again, because that's going to be week 7 on Saturday. We'll see. Okay. I don't want to make it too rough, but I want to make it so that I can help too, right? Because you might need help. So we'll talk about that. So questions around the stuff we covered today. We covered collision detection. We made our own collision manager. We talked about state pattern and the gang of 4 and different kinds of programming patterns. Okay, we talked about those things. We also talked about assignment 1. That's going to be due next week. Assignment 1 is due, the slot machine is due next week. I'm going to make it due on Sunday. I know it's due Saturday. I'm going to push it one day to Sunday to give you an extra day. Okay? And this project part 3 is, instead of being due today, it's due tomorrow to give you an extra day. I don't know why. Maybe it's because of the snow and the cold. I'm just pushing it one day to give you extra time. And also I gave you more stuff today. So if you want to use start, play, and end, this whole scene, this week's GitHub repo, if you want to use that for your first playable, you may. However, you don't have to, because the first playable does not require more than one scene. All I'm looking for is one scene in the first playable, some movement, basic collision detection. That's all I'm looking for, and that's it. Show me some backgrounds. Let me give me a sense of what you're doing. That's what I'm looking for your first playable. Okay? Your game design document. Some people asked about this. I got to talk about your game design document. It's a work in progress. It's a living document. You're going to put some stuff that you know right now. For example, you may not have the final version of all your assets. You may not have that. You may have some placeholders you're using. You probably don't have any screenshots, and if you do, they're probably limited. Not all the screenshots are there, right? One thing I've removed is this thing to put it up on online right now. I haven't talked about how to put this thing up online. Sure, we're making a web game, but right now it's locked on your computer. Next week, maybe, we'll see if we can put this up online for you guys. So make it live, so anyone in the world can see it. There's a few steps. There's a process. And once we get through this process, it's going to be perfect. Okay? Questions? Guys, thank you so much for attending. I'm going to let you guys go a little bit early today. Oh my God. The other class I kept 25 minutes later, because that's how long it took me to get everything done. Okay, guys, thanks so much.